You guys hear me okay? So, my name is Jules Urbach, and I'm CEO of Otoy. Otoy is a cloud rendering company, and that is a pretty broad term, and we focus on a lot of different elements of creating reality. Um, for virtual reality, now that we have things like the Oculus Rift, right? Hello? Can you hear?
Yeah, get it real close to your face.
All right.
Let's keep the chatter down for this last speaker. Let's give him our full attention.
Thank you. Can you guys hear me okay now? Good. So Otoy actually is very focused on three parts of rendering. First is capture. You know, we've been hearing from a lot of different artists tonight about how difficult it is to capture films and cinema in 360. You know, really none of those things even begin to address the problem of how you would navigate through a scene that you capture, right? I mean, do you have multiple cameras? Do you have some sort of magic holographic recorder? And ultimately, when it comes to how you imagine art and CG and performances being merged together, when you think about it, a truck or clothing, and these are manufactured things, so is a set. So I think if you can make CG look real, and you can capture things from the real world, namely performances and actors, in a way that fits perfectly with that, then you have something really interesting, and then you might be able to crack the problem of how do you render something as a volume rather than just a sphere around you, which is really a huge step up from having a 2D image. But having a volume is really the magic point between us, where we are now with VR, and the holodeck. So I want to basically talk about our renderer, which is a big part of how we make things look real in CG. This has been on the market for a while. It utilizes GPUs, which are typically used for video games, but the results look amazing, and you can render these on your desktop. This is using 3D Studio Max with our plugin, and the plugin renders the physics of light. There's no real shaders. This is a truck you can get for Evermotion for $30, and our engineer wrote the little algorithm that generated the grass and the trees and the roads, and it looks really good.
Yeah.
And that takes 4 minutes to render on 4 NVIDIA cards, which are $500 each. So this used to take. I mean, there are people here probably here from Pixar and other ILM, right? I mean, GPU rendering looks really good, and it is about 10 to 30 times faster than doing the same thing on the CPU. We built a CPU version of this renderer, and it runs about that much slower on the same cost. What's interesting is that 4 GPUs is something you can really put on one computer, give that to one artist, and as you guys will see a little bit later in the presentation, when you're composing the scene, you see it being lit live. Like, there's no waiting for this to render. It's a little bit grainy, a little bit noisy, but you end up with something that is absolutely real. And the physics of light and motion and everything else are really taken care of for you. You don't need to be a shader monkey or learn shader graphics programming to get amazing results. And we have 100,000 users, many of them students that have been doing things like this for a couple of years now since the software has been on the market. Going forward, we're going to put this in the cloud so that we can render not just images, but actual full volumes of scenes. And so I think this covers a lot of what you can do for the sets and for objects and for things that you can already do well in CG. But a big part of what Otoy is focused on is capturing humans, and specifically faces, right? I mean, that's one of the things where the performances, when you see a close-up shot, that's the magic of an actor's gift to the scene, right? I mean, it's in the way that their eye muscles move. And I think that a lot of CG doesn't quite capture that. I mean, it can look amazing. But what's interesting is this light stage technology. It evolved out of USC. If you guys saw the earlier presentation with that big dome, we commercialized that. And Paul Devevic is a big part of Otoy and what we're doing. And light stage is kind of amazing because it does give you the ability to put something in this dome. And, it could be like a Brundlefly type of dome, right, where you put a full body or if you want to have a close-up shot ahead, and what you get back is a full 3D scan, not just of the surface, but you get normals. And what you're seeing here isn't a photograph; it's actually that light probe, that environment lighting the captured light stage head. So lights, that's great. I mean, I'll keep playing it. I mean, it's now. Here's the thing: this is not new. We've been doing this for 8 years, and we've been in fact, Paul and Tim won an Academy Award in 2010 for their work on Avatar and Benjamin Button, right, where you had the older Brad Pitt using light stage capture. So it's something that's been used on a lot of Hollywood productions and still is, and that's a big part of our company. But really, a lot of the magic in light stage is in the software. So we're thinking about building more portable rigs. Like, we just announced a portable light stage rig that we can ship on to any location. And the next step would be to take things like Project Tango that have really fast depth sensors, multiple cameras, and put the software that generates all this data and that figures out the light field and the reflectance field from an object, and make that part of the consumer cameras that are out there going forward. And that's something that we're trying to get to happen in the next 2 years. If you guys aren't familiar with what a light field or reflectance field is, it's probably worth showing a video. This is sort of show where all these things come together. So a light field is basically what you use to, it's like the negative of hologram, right? It's where all the lighting in a particular volume intersects. And if you're trying to capture an object like this one, a light field is what gives it volume. And you get the Princess Leia effect, right, with a light field display, which you see on the left. That's a prototype that Paul and his team built. Next year, we're building a full-size color version, and it'll be used for characters that are at this size. So right now, that's, we can capture something on the light stage, and we can display it on a little mini light field display. But next year, we'll have a 60-inch cylindrical diameter volume in full color, and it'll be about 500K, which is crazy. But all the work we're doing in terms of rendering and capturing is for this kind of pipeline. And so if you imagine what a holodeck would look like or how it would be created, I mean, light fields would be a big part of that. And I think that, the holodeck itself, I mean, it sort of makes you think about what is it that generates it, right? I mean, when data says, I want a forest, or, I want a Sherlock Holmes scene, I mean, all this stuff is in a database somewhere. And a big part of, I think, the future of cinema VR is making that database accessible. Like what I was saying earlier, where that truck is available on this website for $30 and it goes right into Octane, like that needs to be, that needs to happen continuously, both from assets that are created by artists, but also captures from the real world. So as light stage becomes more commonplace, I think that can improve. I want to show a video from SIGGRAPH because it explains sort of how our streaming technology works in an interesting way, or how our light field rendering technology works. It's pretty cool. I mean, a lot of what is going to be required to take all that data that was used to generate that holographic projector you just saw, or even a light stage capture, you're going to have to compress it, and you're going to have to send it down, and you're going to have to, especially if you're going to try to get it to run on mobile VR, like the Samsung Gear VR that Oculus and Samsung are partnering on. Then it needs to be streamed, and it needs to be able to decode and reproject very quickly. So we brought a little demo for that for you guys to play around with as well at our desk. But let me just play this video. This is from, if you guys are in the visual effects industry, FX Guide is a pretty good publication. It covers a lot of work in the rendering field, and this was their take on this technology.
I want to cross now to our first interview. This is on the show floor. It's with Otoy, and this is my kind of favorite tech. I even tweeted that it's my favorite tech from the show. It is such a mind-bending thing that I'm going to have to even set this up for you. Just to explain, like, kind of, this is probably an end-game solution for a virtual VR helmet, kind of ocular Rift kind of thing. But even without that, it actually works incredibly well. But when looking at it, it looks like we've either canned the demo, or it's somehow been pre-rendered and we're just faking it out, or whatever. But I can promise you, it's all interactive. It has the illusion that you're rendering in real time, absolutely ray traced, photorealistically, a street, and that you could look at it from any angle, and that you can move anywhere you want. Now, of course, we can't render that fast. Like, no one can render that fast. Even the best preview renderers can't do the kind of levels that we're talking about. And yet this is running on incredibly sort of quick, not very expensive hardware, because it's not a very expensive process at the final stage. And so I'm looking at this and I'm going, John, this breaks a couple of laws of physics. Well, it's basically built on light field technology, and light field stuff is some stuff that you might know I love to death. So I went and spoke to the guys at Otoy who have come up with this technology. It's really revolutionary, and I've got to say, a number of people are looking at it. So hopefully you'll be able to piece it together, because I can do as good a job as I can in explaining it when you actually see the footage and hear how they basically came to put these algorithms together. So thanks for joining us. Really appreciate it. I'm
pleasure.
Incredibly impressed by, I guess I'm calling it the holographic display technology. You're calling it light field. What is it that I'm impressed with?
Well, it's both. Light field is a more technical term for holograms, but I think most people are familiar with the holodeck, and that's why in sort of popular culture, when people see something like this, they think of holography. But the idea is that with a single frame of this video, you're able to look around a scene. It's perfect for things like VR. And we're really trying to build the holodeck. I mean, that is the goal of what this technology is designed to provide. This is the first step. So when you get an Urbach holographic video stream, you are able to fully navigate through an environment. It looks completely real, and it decodes on any device, including a mobile phone. A 2D image is a pre-rendered snapshot of a point in space. So what we're doing is we're extending that into a volume, and within that cube, you can walk around, and it is like a living photograph. That experience is what this delivers, and we do actually solve those two problems. We can also render the scene in real time without baking it into a hologram, but that is more expensive. It requires a lot of graphics cards, and there is some noise. So this gets rid of that, turns it into a volume that is largely static, but it can also have motion. We can relight it. There's certain things you can still do with it, and then you have the full. It's even faster than rendering a video game or rasterization based application using OpenGL or DirectX. It's super fast. So it decodes at about 1,000 frames a second, which is perfect for VR, where you want to have very low latency and very fast refresh.
That was 1,000 frames a second, you just said.
Yeah, it's a millisecond.
So that's a big part of it. We showed this really just a month ago. It was just a small part of our booth at Cigarette, but it got all the attention, and deservedly so, because really all this work about capturing and rendering, I mean, coming up with a way to actually transmit it, deliver it, and make it navigable is pretty cool. And so there's obviously, you know, earlier discussions were talking, well, if there's only a format other than MP4s for video, you know, yeah, VR video, and, you know, why does it have to be a sphere? Can it be a volume? All this stuff we've sort of built into the format. But the negatives of what would, I think, become basically holographic video are basically the scene files that we use inside of Octane Render, or the data that's captured from LightStage, which gives you all the material properties, everything that goes inside of that data. So you have a lot of semantic information in addition to rendering this stuff, right? So when we're doing motion, in Octane you can also assign things like audio properties, and we're working with other vendors to help provide actually physically correct audio as well as lighting. So if a manhole drops in the cement, it'll make the correct sound. You don't need to have a Foley guy do it. It'll just work. And that works for a lot of things that are, you know, other than speech and music. Going forward, we want to get this thing onto the VR and DK2 by the end of this year. So we're building a client, an Urbach viewer. It'll be for Android, and it'll also be for PC, Mac, and Linux. There's also a web version. So we're also leveraging, you know, WebVR, which Mozilla introduced, and I think it's being adopted by Chrome and even IE. So if you're in a browser, potentially all this could work. But obviously in native code, we have everything we need to make it all sort of work cohesively. And there's things that you could do in this stream other than just sending down light fields. You can send down 3D mesh data. You can also send down voxels or depth information. And we've also been working on integrating this into game engines like Unreal, so that you can create interactive experiences in addition or to extend cinematic VR. And there's just a lot of different things you can do. It's a Swiss Army knife of, you know, delivering imagery. And so, again, the focus for us in this initial release is really to get this working on mobile. That's where, you know, this year you're going to be able to, you can buy an Oculus, right, in the form of a Samsung headset, and that's huge. I mean, there's going to be 30 million people that will probably buy a Note 4, and you'll be one step away from getting a VR experience on the go, untethered. And so a lot of this work that we did this year was actually sort of pushed forward by John Carmack at Oculus, who had been familiar with our light field work and the compression we're doing, and said, you know, make sure it's out this year. I mean, there's going to be a demand for that on these mobile headsets, and, you know, I think he's right. So it's been a really, you know, exciting journey and path to get there. This is just sort of a little bit of a deeper dive into sort of how the effect works. I mean, you guys saw this in the earlier video, but you do have, just from a single image, like a white light hologram, you can look at it from any angle. So I'm using the DK. I'm actually filming this with my iPhone, and I had the DK2 tracking. Now this is Octane. I'm going to pause the video here just so you guys can see what the tool looks like. It's just, there's no shaders or code really. You can just connect different things together. So some of these things are objects, some of these things are materials, and that node graph, that render graph, is really what's driving that scene. And as you can see, I'm able, in a web page, which is what this is running from, it's in a browser, I can see the scene, I can preview it, I can change all the lighting, and that is running for a few cents a minute. So that's pretty cheap. So you don't have to necessarily go out and buy thousands of dollars worth of graphics cards to use Octane or generate this stuff. And this one is showing a full cube. So you can, the light fields don't have to be constrained to a texture or a square or a cube. It could be anything. It could be, any volume you want. But we were trying to get, to test this with basically walls of light. And this is the truck scene that you guys saw earlier, rendered as a light field. And just one little tiny sliver of that light field, 0.5 millimeter across, is what you're seeing here. Just that it's like one holographic pixel. It's two-sided because it's the full sphere of light coming in, and that's basically, in the physical world, what a light field is. And you combine enough of those together in a box or a square, any shape you want, and you have navigable virtual cinema, which is pretty cool. And by the way, this doesn't need to be saved onto your computer. I mean, the demo we brought is showing basically this exact thing that you're seeing here streamed in with pretty low latency. And you're not just getting a video, you're getting depth information, you're getting deep pixel data, so the VR device can actually reproject as it gets new things in, and it can cache it as well. And that makes for a much more efficient streaming process. And you need to do something similar even for 360 video. I mean, if you look at the at really high-res 60 frames a second 2K 360 video, it's basically 40 megabits a second, and that's way too high to stream over 4G LTE or even most Wi-Fi. So to get that down, you'd want to just send down the parts of the video or the 360 video you're looking at. And this is the same principle, except we're just sending down the volumetric pieces that are closest to you, and we're also not resending down data that is already cached in the viewer. Again, to make all this work, really beyond the desktop, we've been building a cloud service where you can put all the apps that you want inside of a web page. So we've been testing things like Blender, our own tools like Octane, but eventually, one of our major investors is Autodesk. We expect pretty much all 21 applications that Octane and Urbach have a plugin for to be online in a browser. And by the way, we do have an After Effects plugin for Octane. So if you go to render.otoy.com, you can see the beta version of that. We're working on Nuke, and again, we have Unreal and Houdini. Almost every single 3D app that you use today has the ability to sort of work with this format. And we're also building a way of making this rendering power on demand happen per minute. And then there's another element as well to virtual cinema, which is what if you really want to make everything dynamic, right? Where's the line between a video game and VR cinema? Where does that happen? And we're not sure ourselves. The one thing that we wanted to make sure we included in this pipeline was the ability to not just be able to render beautiful scenes that you can then navigate through, even with motion, but to actually make a fully dynamic world that also uses the same principles we used in Octane. So this is a separate engine. It's similar to Octane, and it uses the same Urbach file format, but it's called Brigade, and this is running live. Again, it's running on an Amazon instance, so this is something you can stream. And the entire environment can be fully changed. So this is just like a DirectX video game. You can deform things, you can blow things up, and there's a little bit of noise, but we're actually pretty close to getting rid of that and making it essentially very close to what you guys are seeing with the final render quality in Octane. The limiting factor is that the materials have to be a little bit simpler, but if you're doing anything that requires dynamic input from the viewer, this stuff is going to be a lifesaver. And one of the things that artistically I want to see happen is I'd like to see something like the Kinect, right? Put your body inside of this kind of environment and then have that cast shadows or have that map to your avatar in some sort of game or interactive experience. And for that, we do need to be able to do stuff dynamically and not just render, basically narrative content quickly. So that's what Brigade does, and we're building a tool set that allows you to really mix and match all these different pieces together. And for, as we sort of go beyond rendering, right, we're looking at things like physics and audio. So we've worked with a company called Digital Molecular Matter. They did a lot of the visual effects for physics in Godzilla and Days of Future Past. If you ever played Star Wars The Force Unleashed, the physics in that game were from them. So we're adding that into Octane to give you all the other senses, right? I mean, you need to have that in order to do audio and if you're going to have a sense of touch and what materials feel like, that's a big part of that. And so, yeah, I mean, these are all elements that, you're going to need to give you a full sensory experience, whether you're telling a story or giving somebody an interactive experience that is meant to give them complete presence. One last thing I want to show before I take questions is the integration in Unreal, which is pretty cool. If you guys have ever used the Unreal Engine, this is basically Octane's camera on the left, Unreal on the right. Basically drive the Octane viewport right from within Unreal, so you can create any sort of video if you want tools like Unreal or Unity or other engines, and have that right into this system. So,
all right, give it up. Exciting. There was a lot there. I've got a bunch of questions. I'm sure you guys do too. I'll let you pick who you want to answer questions from. Shoot.
Go ahead. Okay. So, great presentation. What does it take to get? Thank you. What does it take to get to this kind of capture technology more broadly distributed, the light stage technology, into the hands of filmmakers and creators? Because on the face of it, it doesn't actually seem like that piece of the front end technology is really, expensive or complicated. It's a lot of LEDs and some polarizing filters and 6 or 7 cameras, right? Yeah. So have you thought maybe about an open hardware solution and let's spec out to people, here's the setup, here's how you do it, it's going to cost you $50,000 and we sell the software?
Here's the thing. Lightstage was exactly that before we commercialized it. It was done at USC, and Paul Devevic had a page, and you get the data sets and you can see how the cameras are built. It actually takes a lot of calibration and good software to make that work. So my feeling is with the Orbach viewer, we'll have the tools if you have the right calibrated cameras and LED set up to give you that kind of capture system. And we've experimented with just doing things with just 4 LED lights and a DLSR, and you get really good looking stuff with that. So for sure, there's ways of doing that and making that free. I mean, I don't want there to be a barrier for people to be able to put content into this render graph. And a lot of Lightstage is software. I mean, it's not just the LEDs and the cameras. The cameras do need to be high speed if you're capturing motion with all the lighting conditions. But it's, that's not necessarily necessary if you're just doing something like just wanting to scan in an environment or an actor without the ability to fully relight them the way I showed with that earlier presentation. What we're also building as a database, for example, if you take a Lightstage scan, even without all the lighting information from the bigger Lightstage, you can generate really good looking skin with that shader that is just one of the things that one of our users put on the forums. And it looks great. So we're definitely trying to come up with ways of open sourcing this entire ecosystem. Software is hard, and rendering and processing data is pretty difficult, but we're kind of trying to democratize that and make it something you can pay pennies for to, if you need the cloud to do it, or if you have the power on your local machine. Octane's free for students, for example, and we may, we have a demo version that we may eventually turn into a free version as well, so people can really add to this ecosystem. That's a greater value than selling the software, I think.
Cool. Next question.
Well, I was gonna, first of all, testing. First of all, unbelievable. I mean, I went to visual effects school, and I was just like, I've always wanted something like this. So just seeing like real time, like the light bloom when adjusting the basically a skylight, and just seeing the light bloom on the cars and stuff in real time, that's amazing. So I guess the question I had, I noticed when you were moving around, you did, you got it was readjusting and re-rendering, and you get the pixelation and everything.
Yeah.
As far as like compression, have you guys messed around with compression algorithms based upon field of view? So basically, can you compress, you level of detail basically, because the field of view is limited, for humans.
Yeah, I mean,
have you messed around with any algorithms that would you would get higher compression around the central field of view if you were doing like mobile, for example?
Yes, well, that's exactly why the light field. I mean, light fields inherently have that. Did you see that the earlier part of the video where I was showing this truck scene? Just that little tiny piece of it was the whole scene, but blurry, right? So if I just sent that part down, you'd actually be able to look around and see it in a blurry form. The more that I send down, based on where you are in that volume, the clearer that becomes. And it's very much like a hologram, right? You've heard the stories, right? If you crack a holographic print or glass, right? Each little piece of the entire scene is just smaller. That's how the light field stuff works. That's how our streaming works. And the idea is that you can, based on where you're looking, where you are, you're only sending down the pieces that matter, and you're actually sending it down in a video format, if you call it that, that is designed to resolve in a foveated way, right, based on where you're looking, and also to store that information and reuse it later, so that doesn't need to be come down again if the scene is static in that part of the in that part of the environment.
All right, we've got time for 2 more questions.
In the back there.
Talk loud.
All right, so beautiful stuff. I noticed a lot of the environments were fairly static. I was wondering if deforming environments with characters is the issue of too much pre-computation, or just the I/O would be insane. Like what's stopping you from having fields of waving grass or lots and lots of characters?
Nothing. Nothing. It doesn't really take any more to make this in motion than it does. I mean, you're still rendering extra frames because just like a video, you have to render temporally, not just spatially. But we've designed the system for that. So that truck video you saw, I mean, the truck is moving. There is stuff that's in motion. All the grass could be moving. We just didn't animate it, but there's plugins for Macs that could do that. And yeah, I mean, there's no real extra cost to doing animation. It's just another dimension temporally that you have to add. One thing we are working on though is you can render this entire environment, and the pieces that are static. Maybe you have it a loop where the grass is blowing and all the stuff, and that could be one light field, and then the truck could be rendered separately and added to it later. So that's the kind of stuff where, like Photoshop layers, you will be able to sort of composite light fields and reuse them and relight them as well without having to go through that whole rendering process again. But animation is doesn't add any complexity. It just creates more data.
All right, last question. Okay, I'll ask it. I was hoping I'd get to ask one anyways. So you said that the LightStage portable version is going to be available sometime in the next year?
Well, it's available now. We've actually been doing shoots with it, but it's a service, right? I mean, we set it up at a film set or like a museum or something, and we basically can capture, a full day's worth of stuff on it. And it's still a fairly big rig. If you saw the earlier video, if you go online to our YouTube channel, you'll see the portable light stage in the background. It's still about 7 feet tall. Clay, how tall is it again?
It's actually 13 feet tall.
Okay, 13 feet. I'm off by half. It's big, but it folds into crates and you can ship it. But that's a full volumetric capture. If you just want to have something that's light stage-like in place of your camera, we've done that with DLS, regular cameras with about 4 LEDs and a couple of special filters. So we're working on that. That's for next year. But the light stage is something that we can, we're building more of them and we can ship them anywhere and do shoots all day long with them.